morning to one and all. Now in this class we will discuss about 8 queens problem. So here just the before class we have discussed about the backtracking strategy. So by using this backtracking strategy we are going to solve some of the problems: n queens problem, sum of subsets problem, graph coloring problem. So these are the problems which you are going to solve using the backtracking strategy. So first let us quickly discuss about this n queens problem, that is we are having in our syllabus 8 queens problem. Okay, right. So here let us understand what is this n queens problem. Then we will explain how the backtracking is used for solving the problem. Okay, so here by reducing the size of the problem we have taken 4 queens problem. First we understand this 4 queens problem, then we will discuss about 8 queens problem and similarly n queens problem. Okay, so just by reducing the size of the problem we have taken this 4 queens problem. Okay, so here a 4x4 chessboard is given. So the 4x4 chessboard consists of how many cells? So you are having 4 rows and 4 columns, that is totally you are having 16 cells. But a standard chessboard contains 8x8 cells. Okay, so totally you are having 64 cells in the standard chessboard. Okay, so let's see this 4 queens problem. So here 4 queens are given. Okay, so you are given 4 queens. Okay, so it is just the problem is just similar to the game of chess. So in a game of chess a queen will be there which will have its moves like horizontal, that is in a row or in a column or a diagonal it will move. So how a queen is going to move? So it can move horizontally or vertically or diagonally. Here also it is the same queen. So we have places on this board. So all 4 queens we have to place such that so we have to place these 4 queens on the chessboard such that no 2 queens are placed in the same row, same column and in the same diagonal. So this is the condition. So here we are having 4 queens, you have to place these 4 queens on a 4x4 chessboard such that no two queens are placed in the same row, same column and in the same diagonal. So first of all we will see what are all the possible solutions. So you know in backtracking you are going to find a solution by constructing a tree, that is called a solution space tree or a state space tree. So the tree organization for the 4 queens solution space is as follows. So here in backtracking always we should construct the tree in the depth first search manner only. So this you have to keep in your mind. Okay, so you have to construct the tree in the depth first search manner but not in the breadth first search manner. So here this is the solution space tree or the state space tree. So how you are going to construct this tree, let's quickly discuss about this. So this is the starting of the solution. The first queen, okay, x1 is nothing but the first queen, x2 is the second queen, x3 is the third queen and x4 is the fourth queen. So we can place the 4 queens on the chessboard in many ways, so many ways. Okay, so here let us assume the first queen is placed in the first column. So the second queen is placed in the second one, next third column and next fourth column. Okay, so here I am going to generate this tree without considering the constraints. Okay, so this is one arrangement. Okay, next if you see the fourth queen is placed in the third queen is placed in the fourth column and the fourth queen is placed in the third column. So this is one more arrangement. Next, moving one queen backward, that means making the second queen instead of the second place you can move to the third place. Next, the third queen in the second place and fourth queen in the fourth place. And one more arrangement, the third queen in the fourth place and the fourth queen in the second place. Next, moving one backward, so the second queen in the fourth place, third queen in the second place, and fourth queen in the third place. Okay, next, like this. So like that, see, I can place the first queen in the first column, or else I can place the first queen in the second column, or else I can place the first queen in the third column, or I can place the first queen in the fourth column. So like that, you are having so many paths from root to the leaf. All these are the different possibilities, all these are the solutions. See, 4 queens are given, you are asked to place these 4 queens on a chessboard. In how many ways you can arrange means these many ways you can arrange. Okay, so actually here you are going to construct the tree in the depth first search manner, like this. Vertically you are going to move like this. Okay, so you are not constructing like this, so please keep in your mind, this is very very important. In backtracking approach, the solution space tree should be constructed in the depth first search manner only. So if you go for branch and bound strategy, there you are going to construct the tree in breadth first search. So for now you remember that it is constructed like this. So actually these are the nodes. So I have not given any numbering to these nodes, actually you have to give the numbering also. So I later in the material I will show you how we have given this one. So in order to reduce the complexity, in order to make you understand easily how we have drawn this solution space tree, I have drawn like this. So what is this x1? Queen 1. Queen 1 I can place in the first column, queen 2 I can place in the second column, queen 3 I can place in the third column, queen 4 I can place in the fourth column. This is the first possibility. Next, the queen 1 will be in the first and queen 2 will be in the second column only. I can just interchange these two. This is one possibility. So after I have interchanged the queen 3 and queen 4, what I have to do, the next possibility is changing the queen 2. So that's why I have changed the queen 2 from second column to the third column. So like that, I have made different possibilities like this. So this is the 4 queen solution space with attacks. This is the 4 queen solution space with attacks. Attack may be possible. Okay, so totally how many nodes we have generated? If you see here, 1 plus 1 2 3 4, so that's why 1 plus 4 plus, for each one how many nodes you will be generating? 3. So that's why 4 into 3, this one 4 into 3 nodes plus 4 into 3 into 2 nodes plus 4 into 3 into 2 into everything 1 node. So totally how many nodes you are generating? 1 plus 4 plus 4 into 3 plus, like this. So here I can write like this. So for 4 queens I have got this one. So sigma I is equal to 0 to 3, that means 4, 1 2 3 4, 0 to 3. What I am going to do? So I am going to make the product. So 4 into 3 into 2 into 1. So that's why 4 minus j. Sigma I equal to 0 to 3 and product of j equal to 0 to I, 4 minus j. So totally you are getting 65 nodes. Suppose if I take 8 queens, suppose if I take 8 queens, how many nodes I am going to generate? So here I am getting 1 plus sigma I is equal to 0 to 7, so j equal to 0 to I, 8 minus j. Here I am going to get 8 minus j. So here for n queens, how I am going to get? I get 1 plus sigma I equal to 0 to n minus 1, n minus j I am getting here. So now we redraw the tree by applying the bounding function. So by applying the constraint, by using the bounding function, if you apply, then we will get the tree like this. Okay, so this is the actual tree. Without considering the constraints total, you are having these many possibilities. Now what is the constraint? So the queens should not be placed in the same row, in a same column, in the same diagonal. So this is the condition. So let us quickly draw by applying the tree using the bounding function. So you know what is the bounding function? So the bounding function is used to kill the node, okay, where it is going to violate the condition. Okay, right. So this is the 4 queens tree organization solution space by applying the bounding function. So what is this bounding function? How we are going to generate the tree like this? So I am going to place the first queen in the first column, second queen in the second column. So here the constraint is violated. So the first queen is present in the first column, the second queen is present in the second column. So here diagonally they two can attack with each other. So that's why I am going to kill. So no need to generate the other nodes. Why? Because here the condition is violated. So I am going to kill the node by using this bounding function. So I am going to kill this one. I am going to stop here. I am going to stop generating the node here itself. Next, go back. So here instead of 2, I am going to place the second node in the third column. Okay, then there is no problem. So now what are the places left to place the second to place the third queen? So you are having the second column as well as the fourth column. Suppose if I place in the second one, so what happens? So again these two, the second queen and the third queen, will be diagonally present. So the condition is violated. So that's why immediately I am going to kill the node. Next, so what is another possibility? So the first queen is placed in the first column, next second queen is placed in the third column, next the third queen is placed in the fourth column. So what happens? So third column, fourth column. So again it is diagonal. So that's why I am going to kill the node here. Next, another possibility. So like that for each and every possibility we have drawn in the previous tree, you are going to check that one. Wherever the condition is violated, immediately so we are killing the node. So like that this is killed, this is killed, this is killed, and here if you see this one, the first queen is present in the second column, next second queen in the fourth column, third queen in the first column, and fourth queen in the third column. The bounding function is not applied here. Okay, so here we have not applied any bounding function. Okay, so here if we see by using the bounding function, we are going to make this tree organization. We are going to solve the problem using the backtracking. So now we have to continue further like this, this one like that. So here up to here we got one solution. So like that, if you proceed by applying the bounding function, so then you are going to get another solution also. So here the solution is expressed as an tuple. So this is one solution. Why? Because from root to leaf node you are having a path. Okay, the bounding function is not applied means what is the meaning here? Here the bounding function is not applied. What is the meaning? The constraint is not violated, and this is the desired solution, one of the desired solution. So what is this here? If I arrange queen 1 in the first queen in the second column, second queen in the fourth column, third queen in the first column, and fourth queen in the third column, so here the solution is expressed as a 4 tuple like this, 2 4 1 3. So if you consider the mirror image of the same solution, that is also one of the possibility. Okay, so 3 1 4 2, this is also another solution. So finally you are going to arrange the queens like this. So first queen here, first queen, next second queen is arranged in the fourth column, third queen is arranged in the first column, fourth queen is arranged in the third column. This is, so if you arrange like this, then no queen is present in the same row, no queen is present in the same column, no queen is present in the same diagonal. So this is one of the possibility, this is one of the solution, and exact replica, that is mirror image of this, this is the another solution. Okay. So like this you are going to solve the 4 queens problem. Let's quickly discuss about the problem, that is the thing present in the material. So 4 queens problem is there. So consider the 4 by 4 chessboard is there. So finally you are going to derive a solution in the form of a 4 tuple we have just now seen. So the explicit constraints is this one. Implicit constraint is no 2 queens are present in the same row, same column or the same diagonal. So this is the solution space tree for this 4 queens problem. See here, I have told you previously, each and every node in the order they are created, I have given the numbering also. So that is depth first search 1, 2, 3, 4, 5. So like that we have seen this tree. I have not given the numbering there. Now you can see the numbering. So the tree organization of the 4 queens, the nodes are numbered as in depth first search. So the steps that are used in the backtracking are as follows. See this one. This is very interesting. You can clearly understand this one. First I am going to place the first queen here in the first column. Okay, right. Now I have to place the second queen. Okay, so I should not place here. Why? Because it will be presenting in the same column. So I should not place here the second queen. Why? Because it will come in the diagonal. So that's why what is the position means I will place here. Suppose now I have to place the third queen. So I can have this one, this one, this one. 4 places are there for placing the third queen. Okay. Now if you see, if I place here queen 1 is already present in this column. If I consider here, it will become the diagonal for this second queen. If I don't place here, why? Because in the same column. I don't place here, why? Because again it will come in the diagonal. Then what I have to do now, I am unable to place the third queen in any one of these positions. So that's why I am going to change the position of the second queen. So instead of placing in the third place, I am going to place in the fourth. So now I can arrange the third queen in this is not possible, so I can arrange here. Okay, right. Now I have to place the fourth queen. So if I see if I want to place the fourth queen, so here I am unable to place. Why? Because already first queen is present. So here already third queen is present. So here it will come as a diagonal. So here it is already present. So now it is not possible. So that's why I have to go. So that's why there is no possibility here. So I am going to backtrack and again I am going to change the position of the first queen. So instead of placing here, I am going to change here. Now I can place the second queen here. Why? Because this is the suitable place for placing the second queen. Next I can place third queen here. So the conditions are not violated. So no row, no column, no diagonal. Next finally I can place the fourth queen here. So this is the one of the solution. So if you see, the portion of the tree that is generated during backtracking is shown in the next figure. Okay, so the nodes are killed using the bounding function that we have previously seen. So let's see that one. So by using backtracking, by using the bounding function, if I draw, I will get the tree like this. So here what is meant by B? So the condition is violated here. Why? Because the Q1 is present in the first column, Q2 is present in the second column, they become in the diagonal, the condition is violated. So that's why the node is killed using the bounding function. So that is the meaning of B. So from here you are not going to generate any tree. Okay, so like that if you trace the tree, so here you are going to get one of the solution, that is 2, 4, 1, 3. This is one of the solution. Like that if you continue the remaining portion of the trees also, you are going to get the another solution, that is 3, 1, 2, 4, which I have discussed just now. Now what is the backtracking algorithm? Okay, so whenever you are going to satisfy the both conditions, okay, then only you are going to make it as a final solution. So when you are going to satisfy both, then write off x comma x of 1 is to 10. That means here you are going to finally how you are going to make the solution means you are going to generate in the form of a tuple, that is nothing but a array x. So that's why, so this is the algorithm here. So previously you have seen the recursive backtracking method, and this is the iterative backtracking method, the same thing but iterative one. Okay, so that is recursive. Previously you have seen the same thing. So write off x colon 1 is to k. So how we are going to find the efficiency of the backtracking? You are having an algorithm for this. Next, these are the applications. Okay, so 8 queens problem, sum of subsets problem, graph coloring, Hamiltonian cycles. We will discuss one by one in the next videos. So 8 queens problem. So here what is the actual problem? It is not 4th queens problem. First we are going to discuss the 4 queens problem. If we understand that one, we are entering into the 8 queens problem. So 8 by 8 chessboard is given. Then so when you can say attack will be performed when the queens are placed in the same row, same column or the same diagonal. So finally how we are going to obtain the solution in the form of an array. Okay, so the constraints, implicit constraints as well as explicit constraints. So here the condition is how you can know whether a particular queens, two queens are present in the same diagonal or not. Here let us assume a queen is present in the position I comma j and another queen is present in the position k comma l. Then here if I minus j is equal to k minus l, then both queens are present in the diagonal. This is the condition for checking. This is very important. Please note down. So here in 8 by 8 or 8 queens problem, how we are going to check the diagonal condition means if I minus j is equal to k minus l. So and also every element on the same diagonal goes upper right to lower left. This is another condition. I plus j is equal to k plus l. Okay, so in general we can combine these two and we can write like this: modulus of j minus l is equal to I minus k. Then the two queens are present in a diagonal where you have to cancel the node using the bounding function. So this is the algorithm when we have to place a new queen. So this is the algorithm for this. So here the solution for this n queens problem, small algorithm is there. So here finally for 8 queens problem, how we are going to find the solution? See here. So this is the final solution for placing the queens in the 8 by 8 chessboard such that no queen is present in the same row, same column, same diagonal. So this is the solution you are going to obtain by using the backtracking. Okay, so 4 6 8 2 7 1 3 5. What is the meaning this here? What it represents? The first queen, this is the column number of the first queen, this is the column number of the second queen where it has been placed. So if you take the exact replica of this one, so that is also a solution for the, that is 5 3 1 7 2 8 6 4 is also the another solution for the 8 queens problem. So hope you understand this 8 queens problem. So thank you all.